Good day, everyone, and welcome to this year's Dynamic Cycle webinar series powered by Taghleef Industries. I am Monica Battistella, Product Manager and Sustainability Advisor from Taghleef, and I will be your moderator for today's session. We are thrilled to have all of you with us for our very first webinar for the year, and I'm sure that our topic for today will be very exciting for you. What do you think, Adam?
Yes, Monica, absolutely. And today we'll be joined by one other of the companies who, along with Taghleef, contributed to the very recent Licella KitKat project here in Australia. Project KitKat, as it was termed by the contributing parties, was a collaborative partnership formed and facilitated by Nestlé Oceania, whereby a normally linear supply chain was altered and enhanced with the purpose to trial for the very first time in Australia a truly circular value chain approach to flexible packaging waste. I am Adam Stewart, Research and Development Manager for Taghleef Industries in Asia Pacific, and I'm excited to co-host this first Dynamic Cycle webinar here in Australia, along with Monica. Dynamic Cycle is Taghleef's global sustainability approach that not only promotes the use of sustainable solutions, but also aims to share Taghleef's advanced know-how. Dynamic Cycle is designed to act as a trusted consulting resource and to assist in guiding the important interactions with varied partners and stakeholders that contribute to the quality of life of future generations.
You're right, Adam. And for this year's webinar series, our theme is all about reDESIGN. reDESIGN is a tailor-fit service by Taghleef, wherein our very own TI experts facilitate the switch of customers and partners from using traditional materials to a more innovative and sustainable solution. We carefully assess the needs of our customers and collaborate with them so that together we can find and redesign the packaging that is most suitable for their needs. We will talk about different redesign options in every webinar session, so don't forget to follow Taghleef's LinkedIn and Twitter pages for the latest updates. You can also visit our website, that's www.dynamiccycle.ti-films.com. So you can sign up and know more about our upcoming webinars for the year. Now, if you have any questions for today's presentation, you're very much welcome to type them in through the chat box, and we will answer them during the Q&A session. Adam, over to you to finally introduce our speaker for today.
Thank you again, Monica. This afternoon, as mentioned earlier, we are joined by one other of the Project KitKat consortium member companies. Taghleef and 6 other organisations came together to create a prototype for Australia's first polypropylene food wrapper made with chemically recycled content. Our speaker today is the Head of Commercialisation for Licella Holdings. Licella is an innovative technology company which is focused on a lower carbon future. The primary technology, invented here in Australia, is designed to provide for a true circular solution for problem plastic and is complementary to the principles of dynamic cycle and reDESIGN. Our presenter today joined Licella in 2008, focusing on opportunities for the technology in Europe and assisting with capital raising while developing the business commercialisation strategy. He has had a successful career commercialising technology in the software and clean tech sectors. Furthermore, he is the country lead for Australia on IEA Bioenergy's Task 39, commercialising advanced liquid biofuels. He has also been involved in 2 successful clean tech startups, Energy Efficiency Limited in the UK and Horizon Technologies in Australia, which was the first organisation to receive Australian government funding via the CVC REEF program. Let us welcome Mr. Steve Rogers. Hi again, Steve.
Hello, Adam, and thank you very much for that very kind introduction, and indeed to Monica and everyone at Taghleef for asking me to tell a little of the story of what we've been up to, and indeed to all of you for because it, as we're going to talk about in the next 20 minutes, is what this, in order to redesign these supply lines, what we need to do is we need to actually all work out how we can all collaborate together. So I am going to just the safe harbor statement here, which is important, especially given some of the announcements that some of you may have heard a little bit about on Licella recently. But in terms of what we're going to talk a bit about today, really just a bit of a scene setter as to, you know, what we mean by some of these collaborations. Then a little bit about Licella. We're as Adam said, we're a startup here in Australia, but just explain to you who we are and how we collaborate around the world. Then a bit about our technology, and then specifically into, you know, this really exciting project, which was Project KitKat, and then how we're seeing how we're going to look to leverage that prototype to really sort of get advanced recycling happening around Australia to deliver more of the recycled polymers that everyone's after. So just in terms of, we thought, you know, a bit of scene setting, we thought, well, we'd have a bit of a question to start with. I'm sure most of the people on the call will know this lady's name, but the question really is do you know who she is, just to look at her? So we're just going to have a quick poll just to start with, just to sort of get you sort of engaged. And I think the polls come up. So the question is, how many of you know who this lady is? And we'll give you the results of the poll later in the presentation. And then now we're going to just play a video by her.
In 2016, our report showed that if we continue with business as usual, there'll be more plastic than fish in the ocean by 2050. This new Breaking the Plastic Wave study shows that even if we do everything we physically can, every technology deployed that we understand today, we can only reduce the flow of plastic packaging into the ocean by 80% by 2040. That's the next 20 years. But we need to do more. Millions of dollars are being spent on cleaning up beaches, rivers, streets, recycling. But it's not enough, because all that will be in vain if we continue to pour plastic packaging which has no value into the economy. We need to tackle this flood at source. We need to go to the beginning of the system, so every piece of plastic that is manufactured has a value. We need to eliminate all the plastic we don't need. We need to innovate for the plastic we do, making sure it is reusable, recyclable and compostable. And importantly, we need to circulate everything we produce, be that plastic or a biological component which replaces it. That's what sits behind the global commitment. This is the vision of the new Plastics Economy Global Commitment, and this is the vision that over 450 organisations, including some of the biggest companies in the world, countries, regions have signed up to. We've already seen significant action, and these include reducing the amount of virgin plastics which enter the global economy, radical innovation in the way businesses operate and provide solutions to their customers, and billions of dollars that have been committed to increase the use of recycled plastic around the world, keeping it in the economy and out of the ocean. But we need to raise our level of ambition and match it with bold and urgent action to accelerate the transition to a circular economy for plastics.
There you go, and well, as you all now know, that's Ellen MacArthur, and yeah, just 25% of you got that right. But I mean, we all know who Ellen MacArthur is, and we're all inspired by her passion about, you know, really sort of combating, coming up with ideas about how we know we must, you know, address the challenges that the plastics produce, and of course she knew it firsthand, being a sailor. So whilst Ellen MacArthur talks about this, and some of those statistics are used to galvanize the industry, you know, practically, you know, in order to get results, what we actually need to do is we need to sort of engage collaboratively together in working in collaborative solutions. And this is another example of that, you know, with C-Flex, which you know, for those of you in Europe, you know, are clearly familiar with. which is actually looking at how we can get the flexibles, the circular economy for flexibles going. And of course, Taghleef take a leading role in that role. And it's about that type of collaboration that we've really got to sort of work together to actually achieve the circular economy that we're all striving for. So just a bit about Licella and who we are. So Licella Holdings is the holding company, and you can see on this chart underneath here we have a technology which we call the KAT HTR. It's a hydrothermal liquefaction technology, which basically means that we're using water at high temperature and under pressure. And we use that to depolymerize various types of feedstocks. So it's the same, it's a core platform that we use, and then that platform is adapted for using on different feedstocks. And we can see, you may have heard of Mura, who are our JV partner in Europe, outside of Australia and New Zealand, who are working on end-of-life plastics, and recently there's been some announcements there which we'll talk a bit about in the future. But we also, the technology can equally work just as well on biomass as well, to depolymerize the biomass. And in Australia, we work with partners here. So it's the same core technology, different operating conditions basing on the different products that we're trying to process, but a core technology. So obviously the focus of today is around plastics, and specifically what we're focusing on is in the area of end-of-life plastics. So what we're seeing is clearly there have been solutions by mechanically recycling, which have enabled us to sort of use polymers in certain areas, and obviously PET bottles and HDPE milk bottles and things like that are two plastics that we all know that can regularly be recycled. But we also know that there are limits in terms of how much can be mechanically recycled, especially if we're talking about trying to get towards higher reuse levels in the food area. So if we're after food grade areas, we know that mechanical has its limitations, but we also know that we need a combination of both mechanical recycling and advanced recycling, which previously was known as chemical recycling, to help increase the return rate. So we're focusing on taking those end-of-life plastics, processing them through our process to produce a synthetic crude oil. And the process is, as I said, it's really just combining it with water. And when water gets into this supercritical state, it depolymerizes the plastics and produces the synthetic crude oil. And you can see to the right of that, and that synthetic crude oil is just like fossil crude, which has a range of products within it. And because it's a process, what we're able to do with our process is we're able to tilt the process. So if we want to produce more of the lighter products, because all we're doing is we're taking these long chain polymers and chopping them up, the longer we're in the reactors and the longer time that we're talking about chopping it up, the more of the lighter products that we can produce. And you can see that in the bottom slide there. And if you want more of the heavier products, well, then we would just effectively only keep it in the reactor for a shorter period of time. And we're talking about between 20 minutes and 30 minutes. So the ability to flex about it, which is one of the differences between it and other technologies in the thermal area. And clearly, in this space, hydrothermal technology, hydrothermal is different, is often compared to pyrolysis. People often say, oh, you're a pyrolysis technology, but we're not. And I'll just talk about some, a couple of the key differences here. Pyrolysis, when you're basically in order to crack plastics, you need to get to the reaction temperature, and polyethylene is probably the hardest plastic, to crack, and you need to get into that 440, 450 range. That doesn't matter whether it's using hydrothermal or pyrolysis, you've got to get to that temperature. So the traditional approach with pyrolysis is you heat from the outside in. And so you need to apply heat, and then that diffuses. But clearly you have the thermal losses as you go across that transmission area. And also you have the buildup of differences in temperature, which cause char to build up on the outsides of the reactors. And that means you've got losses, and it also means that you have to have higher temperatures when you're doing it. You're using more energy. If you're mixing your plastics with your supercritical water, they're actually mixed in with the medium that is actually doing the depolymerization. So we don't need to go as hot. It also means that we're able to get higher rates of conversion because we're not creating that char. And so you can see there's a considerable increase in yields that can be achieved. We're more efficient because we're actually doing it at lower temperatures. And also when people are talking about plastics, we're not getting anywhere close to the temperatures at which some of the nasty dioxins and things like that, which have given plastic conversion technologies a bad name. So those are just some of the key differentiators. And yeah, we also have the ability to handle the chlorinated any chlorinated plastics that come through easier because the chlorine goes to the water and then it transfers out as salt in the process. But so now on to the sort of the collaboration side of things, and this was a trial that we started with Nestle because we're basically saying, okay, if we want to, soft plastics are one of the sort of the challenges in this space, and you say, well, how do we actually, go about doing this? And this was a collaboration that we did with Nestle and also with one of the councils and one of the innovative MRF facilities, the materials recovery facilities. And what the trial was about effectively was trying to get the plastics, the soft plastics in the home separated out of the MSW. And so the idea is that the council delivers, to the households. And what we did in this study is we got about 2,000 households to volunteer because we wanted to sort of prove the process out. But what they did is they basically put their soft plastics in a separate bag, and then that bag went into the recycling bin, which normally gets collected and then gets taken to the material recycling facility. So really what we're doing is we're taking the plastics out of the what you normally call the residual waste bin, put it into a separate bag, and then that bag is taken to the MRF and then it's separated out there. And we had an incredible response, to that. It really shows that if you engage well with the community, you educate with them, you talk to them, you give them feedback, you get really good levels of commitment and buy-in to it. And that's key to this, is how we actually start this journey of how we take plastics, old plastics that haven't been used before, and take them back around again. And that study is continuing. So off the back of that, we then said, okay, well, if we can collect these plastics, then how do we take those plastics and convert them back into new plastics? And so this was as Adam talked about earlier, this was what we got named as Project KitKat. And so if you can see down there at about 8 o'clock, you can see those yellow bags. Those yellow bags were combined with bags by our partner IQ Renew. And what we've got there is a combination of those yellow bags returned to the material recycling facility by householders, and also bags that were collected as at supermarkets in Australia. You can also return that. So we used a combination of those bags, but most of them were these packaging type materials or soft LDPE type products. Those plastics came to us. We then processed them and converted them using our process into the synthetic crude oil. And then what we did is we took the crude oil and we put it into the refinery near Melbourne, which was the Viva refinery there, and they co-processed that with their fossil material, and then from that. Some recycled propylene was then transferred across to LyondellBasell, who are the resin manufacturer who are connected to the Viva refinery. Then from there, the resin was passed on to Taghleef, who were able to make the BOP, and then the BOP was then passed on to Amcor, who printed the labels and delivered those through to Nestle. So you can see there that's a true, example of the circular economy in action. And really what that's done is it's shown to us all that, you know, if we all work together, and it was a fantastic collaboration done in a really tight time frame, but it just shows you what is possible if everyone has the real will to make this actually happen. So what we're now trying to do is, following this announcement in the UK, whereby the first commercial plant of our technology up in the northeast of England is being constructed, and following on from the announcement which some of you may have seen last week with Dow, what we're now trying to do is actually trying to scale our technology up globally to actually start delivering on these large volumes of recycled polymers that people are after, using those types of innovative solutions that we've talked about. And so specifically in Australia, we've got a feasibility study which we're looking at, and this is in Melbourne, as I said, so you can see Melbourne up there in the top right-hand corner. And in that area, we've currently got two refineries and 2 polymer manufacturers, and so we're looking at the best site that we could actually use. And a number of parties have joined us in this study, which is looking at a whole series of elements, which is really looking at, you know, the brand demand and where the feedstocks are going to be coming from, what the best site is, you know, looking at the provenance of the whole piece to ensure that the plastics are coming back and they are truly recycled. And those are the elements that we're actually using to put together this first of its kind project. And again, this study has again been sort of supported by a number of the parties who are in, you know, that Project KitKat. So again, another great example of us working together with the parties in the supply chain to actually work out how that's going to happen. And then the idea is to get that first plant established in Australia. And then from that, we can see that there's the ability to then scale that technology around the rest of Australia. And from that perspective, we can then see that, you know, there's a pathway for us to take this, not just producing 17,000 tonnes, which will be the first plant's output, but taking this to a stage where we can be producing over 500,000 tonnes of recycled oil made from plastics. So that's just a very quick sort of tour around, you know, what we're doing, the collaboration that's possible, and indeed the journey we're on to sort of help work with everyone in the supply chain to deliver what we all want, which is to try and create a circular economy for plastics. So thank you again for the opportunity of talking, Monica and Adam, and I think we've got some Q&A afterwards, so we'll talk to you then. Thank you.
Thank you very much, Steve, for your presentation. Very interesting indeed. The whole principle of circularity is very much in line with our real-life initiatives, which target the use of recycled PP and PP waste in our product portfolio. Now, as I mentioned earlier, we will be answering some questions that you sent us. So for the very first one, we have the following. There's a bit of a supply and demand mismatch in terms of recycled plastics availability across the US and the EU. What does the situation look like in Australia specifically?
Yes, well, as Adam will say, you know, we've all been besieged, I think, since that project, with people wanting supply, and the reality is there is no supply at the moment, you know, so that's what we're all trying to do. We believe, you know, there's something like between 5 and 6 million tonnes of commitments out there in terms of people saying that they're going, you know, brands wanting supply of this, you know, and the polymer manufacturers say they're going to make it, but it's just not there at the moment, which is why, you know, initiatives such as this, which look at how we can actually, you know, bring plants to market and then scale that, it's so important. And to be frank, why it's so refreshing that everyone is working together, because the reality is we all have to work together to make this happen. You know, it's not, no one party can make it happen. We all need it. If any one part of that chain breaks down, you don't have that circularity.
Thanks, Steve. Very interesting. I do have another question here too. How does working with recycled plastic differ from virgin plastic? What are the main R&D considerations?
Yes, well, I think that the reality is that clearly as you can see in that example there, making recycled polymers is much more complicated than it is making virgin polymers. The virgin polymer industry has been evolving over the past 50, 60, 70 years and is highly efficient. And is able to make virgin polymers really efficiently. Taking fossil feedstocks and converting them. The reality is that if you're going to convert it from waste, we did a calculation that we would need 630,000 KitKat wrappers to make a ton of recycled plastic. Which we could then convert, to 85% of that through to oil. So it just shows you the scale of what's needed. And I think, what we've shown is it is possible. We've cleaned up plastics, all sorts of plastics, everything from plastics recovered from landfill through to plastics recovered from paper recycling facilities, through to paper recycling rejects from MRFs, from as well as those ones that we've sort of saw separated at the front. So we've been able to show that we can clean all of that up. It's all possible. The reality is, though, the cost is going to be the challenge, right? Putting a supply chain in place like that initially it's going to cost more, just as all of these sustainable solutions do. I mean, if we look at a sustainable aviation fuel and things like that, the reality of that is, that costs 3 times as much to make, and the reason for it is it's more difficult, it's more complicated, especially in these early stages.
Thank you, Steve. And for the next question, how do you see development of chemical recycling in Australia, and in your opinion, which are the necessary next steps that will allow for further investments in this direction?
Yeah, I mean, with any new technology, the first thing is you have to prove that it works, and you have to prove that it works at scale. So the key thing is that for our technology and everyone else's technologies, it's about getting these pioneer plants working. Everyone from an investment perspective, everyone else wants to be. There's a term saying everyone wants to be first to be second. But the reality is you've got to get that first plant built, and then once that works, then I have no doubt that the ability to have follow-on projects will be very easy. In Australia, there's over 2.5 million tons of plastic each year goes into landfill, and so there's no shortage of that. We just got to sort of demonstrate that we can collect it, convert it. And then I think, the sky's the limit. It's just you have to get those first plants built, which is what we're focused on.
Thanks again, Steve. I do have one more question from the audience. What was the initial plastic waste quantity used in the test run of chemical recycling, as in Project KitKat?
Yeah, so we converted just under a ton of plastics. And then sort of that went round, and it was about 350 or 35% of that was coming from that collection from the households, and then the balance was from the store. We have a scheme called reDESIGN here, where they recycle it back, where people take their plastics back to supermarkets. Does that answer the question?
Thank you.
And for the next one, maybe we still have time for a question. What happens to the water in the reactor, and is the process very water intensive?
Yeah, no. So the answer is no. It's not. We get very high. We think. We can process between 65, about 65% plastics with the slurry, 65 to 70% slurry. And then, so clearly, if we're processing 20,000 tons of plastics, that's about 7,000 tons a year of water. So it's not a lot. But the benefit that we have is that we are able to clean that water up again. So the water itself, because once it comes out of the reactor, It is normal water. It has some contaminants in it in terms of mostly organic contaminants coming from the plastics. As I said, there are some chlorine which goes to the salts, but a packaged water cleanup process is possible, and that's what we're looking at. It's very simple.
So thank you, Steve. I'm afraid that's all the time we have for today's webinar, but we've taken note of all the questions and we will get back to you on this via email. Thank you very much, Steve, for joining us, and it's a real pleasure to have you grace our first Dynamic Cycle webinar series for the year.
Indeed. Thank you, Monica, and thank you, Steve, for today. I absolutely enjoyed this session with you both. Thank you to all of you for joining us today, and we look forward to seeing you in the next webinar.
To know more about our upcoming webinars, you may follow our LinkedIn and Twitter page, or you may also visit dynamiccycle.ti-films.com. Thank you all and see you in our next webinar.